Previously, we have started the compound nucleus, theory of compound nucleus, and we have seen the concept of compound nucleus, how the compound nucleus form. Today, we are going to look into the excitation state of the compound nucleus. In that, the first one is the energy of excitation. How do you get the energy of excitation? The total energy of excitation of a compound nucleus is the result of two contributions. It's the result of two contributions. The first one is the kinetic energy of the projectile on center mass system. Kinetic energy of the projectile. Second is the binding energy of the particle in the compound nucleus. Binding energy of the particle in the compound nucleus. This can be illustrated by using the following example and its calculations. The reaction is the bombardment of magnesium by 8 MeV deuterons. What is the nuclear reaction? This bombardment of magnesium by deuterons means here the magnesium is the target and this deuteron is the projectile. Magnesium is the target and deuteron is the projectile. And its energy of deuteron is 8 MeV. Energy of deuteron is 8 MeV. Means it's a initial kinetic energy of the incident particle or projectile. Our projectile here is the deuteron. Incident kinetic energy, initial kinetic energy of the incident particle. The reaction is bombardment of magnesium by 8 MeV deuterons. The compound nucleus form being aluminium 25, whose excitation energy is the sum of two terms. As we know, the excitation energy of compound nucleus is calculated or obtained by the contribution of these two terms. The first one is kinetic energy of projectile and second is binding energy of the particle in the compound nucleus. And in this reaction, magnesium strikes with deuteron. In this reaction, the compound nucleus form is aluminium 25. It's not the product, it's a compound nucleus. And after it decay of the compound nucleus, you will get the products. So this is the middle stage, that formation of compound nucleus. Here in this case, the compound nucleus is aluminium 25. So the excitation energy of this compound nucleus can be calculated. The first is kinetic energy of deuteron in striking the magnesium 24 nucleus on center mass system, and this can be calculated kinetic energy of the incident particle by our previous equation. We have seen the previous equation. This term is called as kinetic energy of the incident particle on center mass system. This term is called that. So, and this is obtained as the difference between the kinetic energy of the initial particle and after scattered. So from this equation you can get the kinetic energy of the deuteron. So here m is the capital M is the mass of target, mass number of target. Small m is the mass of incident particle and this target, and this is the initial kinetic energy of the incident or projectile. Initial kinetic energy of the projectile. This kinetic energy is on the after the striking the target. This kinetic energy is the after striking the target. This is called a center mass system, and we have to include the mass of projectile also and mass of target also. So from this equation you can get the kinetic energy of deuteron in striking the magnesium 24 nucleus on center mass system. So according to this equation we have taken m is 24, mass of target is 24, divided by the mass of projectile plus mass of target, so it's 26. So 24 by 26 into Ta. Ta is the initial kinetic energy of the projectile, and it is given that the 8 MeV deuterons. So this 8 MeV is the initial kinetic energy of the deuteron. So we have taken 8 here. So after solving this you will get this 7.38 MeV is the kinetic energy of deuteron in striking the magnesium 24 nucleus on center mass system. And second contribution for excitation energy is the binding energy of deuteron in compound nucleus. Binding energy of deuteron in compound nucleus. So binding energy we know with a well-known equation. The mass difference into 931. Delta M is the mass loss. And mass loss here in this case in nuclear reactions, the mass loss is the mass of reactants minus mass of products, or here is the compound nucleus. So mass of reactants means Mg24, mass of magnesium 24 plus mass of deuterons. This is the LH side, right? So target plus projectile, and minus mass of compound nucleus, which is 4, and into 931. So these are the actual masses in atomic mass units. So this is the mass for magnesium 24, this is the mass for deuteron, and this is the mass for aluminium. And after solving this and multiplying with the factor 931, you will get 11.40 MeV is the binding energy of deuteron in aluminium 25, means in compound nucleus. So you will get the binding energy, you will get the kinetic energy of deuteron and binding energy of deuteron, and the excitation energy is now this contribution of these two terms. So hence excitation energy of the compound nucleus aluminium 26 is the sum of kinetic energy of deuteron in CMS plus binding energy in the compound nucleus. So it comes to the 18.78 MeV. So this is the energy of excitation, and these calculations are important from the point of the problem solving. So this is first the energy of excitation in case of excitation state of compound nucleus, energy of excitation. Second is distribution of excitation energy. So how that excitation energy distributes in the compound nucleus. As mentioned earlier, total excitation energy is distributed randomly between the nucleons of the compound nucleus. Once the compound nucleus forms, as we know, in any nucleus or in any nuclei, the nucleons are present, and nucleons are protons and neutrons. So in compound nucleus also protons and neutrons are present. So this excitation energy is randomly distributed between the nucleons of compound nucleus, and probability of uniform distribution is lowest, is very low, and random distribution is more probable. For example, in magnesium deuterium, as described in previous slide, magnesium deuteron reaction, if excitation energy is this, as we have calculated previously, were to be uniformly distributed over the 26 nucleons of the compound nucleus, each nucleon would get about this much 0.72 MeV, and which is too low to effect any nucleon emission. So in order to get the nucleon emission, this much, this amount of the energy having each nucleon will not effect. It is very low to effect any nucleon fission. So this uniform distribution is not possible in order to get nucleon emission. So in such case, nuclear de-excitation can occur only by emitting radiation. In such case, nuclear de-excitation occurs. So this is about the distribution of excitation energy. Excitation energy is mostly distributed randomly. So this is the problem 1 based on our previous calculations of excitation energy. So the problem is calculate the excitation energy of compound nucleus formed in the reaction magnesium 24. In previous case, we have again seen the magnesium plus deuteron reaction. Here magnesium 24, alpha is the projectile, proton is the ejectile, and the product is aluminum 27. So whole reaction is shown here. Magnesium 24 is the target, alpha is projectile, P proton is the ejectile and aluminum 27 here is the product. The energy of alpha is 2.75 MeV. Energy of alpha is given, and also given things are mass of magnesium 24, mass of alpha particle, and mass of silicon 28. Silicon 28. Silicon 28 is given here. So this silicon 28 must be the compound nucleus. Silicon 28 must be the compound nucleus, because after absorption or after striking this alpha particle to the magnesium atomic number increased by 2 digits and mass number increased by 4 digits. 24 plus 4, 28, and 12 plus 2, 14. 14 is for silicon. So silicon 28 must be the compound nucleus and its mass is also given. So we have to calculate the excitation energy of this compound nucleus. We know the formulas. So the steps for these calculations are: first step, we have to calculate the kinetic energy of alpha particle in center of mass system, and this can be calculated by using this equation as we have seen in previous case, m by m plus m Ta. Ta is the kinetic energy of initial kinetic energy of incident particle, or here is the alpha particle. Its initial energy is given here, 2.75. So Ta is given, m, capital and small m we know from this reaction. The second step is now then calculate the binding energy of alpha particle in compound nucleus, and here compound nucleus is silicon 28. So here again equation, we have to take the left hand side minus the mass of compound nucleus, reactant minus compound nucleus, and into 931, and once you get this binding energy you will calculate the excitation energy, that 1 plus 2. So summation of these two terms you will get the excitation energy. So in this way you can calculate these, or you can solve this problem by your own way by using these steps, and you have to upload these on the provided link. Thank you.